Hi, this is Igor from hdhead.com. In this Avid DS tutorial, we're going to learn how to create 3D topographic models and how to animate them and also animate them in 3D. Everything in this tutorial applies to any Avid DS version within the last 10 years, except for the stereoscopic part. When it comes to creating anaglyphs, version 10.3 and above have certain tools built in, but it's actually not very difficult to create anaglyphs of your own, which is something we're not going to address in this tutorial, but there's plenty of information on that on the internet. So what would you say if I told you that this environment here was fully modeled and animated in DS and that it only took minutes to render? And now if you would please put your 3D glasses on, we'll take a look at something else. How do we create something like this in DS? Simply using these two pieces of information. On the left, we have an aerial image of a meteor crater in Arizona. On the right, we have a corresponding elevation map for that same area. When we combine those two in Avid DS, we basically get a model with realistic 3D shading. And the elevation map for the crater is used almost like a mold for a sheet metal stamp, where everything that's dark is going to be low, so those are the low-lying areas. Everything that's white is high. So you can see how most of the plateau is sort of grayish, and then around the rim of the crater it's getting more and more white, so that's where the surface is raised, and then it falls off pretty sharply into a total blackness at the bottom of the crater. Here you see what I meant by stamping sheet metal. The map is used to create this geometry, and as you can see, it's pretty coarse. The actual elevation map is not as coarse, but Avid DS 3D DV works in only 8-bit mode, which gives it 256 steps of elevation. It looks pretty rough on this model, but once you apply the texture map, you can no longer see the coarse steps. And where do we get these wonderful maps? Well, there are several places. The source for this is U.S. Geological Survey, at least for the United States, but there are different services around the world that do surveying of different parts of the globe. USGS provides all kinds of information for the United States, and the elevation maps, which are known under acronym of NED, I think it stands for National Elevation Dataset, can be downloaded from seamless.usgs.gov. There's another service by USGS called Earth Explorer, which gives you easy access to the tiles that create the seamless map for NEDs and aerial photographic images and all kinds of different texture maps that you can use. But I have to say that both of these websites are sometimes very slow, and especially the Seamless website is kind of difficult to use. You almost have to be an engineer to figure out what they're talking about and how to download these things. They're not terribly user-friendly. So what I find more useful are third-party software, and there's one called Global Mapper, which works quite well. Global Mapper allows you to connect to all these different repositories of maps from all over the world and download maps for a selected area. And also, if you download maps through Seamless Data Warehouse or Earth Explorer, it's likely that you would still need to do certain work to those maps. For example, NED maps don't really come as images. As you know, Avid DS can only load images. It can't just load any binary information. But the NEDs come in binary form, and they need to be converted into images before we can load them into Avid DS. Well, Global Mapper is quite useful for that. And it works really well. The only times it hangs up is sometimes when it downloads from these different government repositories. As I said, they can be quite slow, so be prepared to wait when downloading these maps. You may ask, why even bother using DS to create these kinds of animations where you can use Google Earth Pro? That's true. You could use Google Earth Pro. It's not free. Unlike Google Earth, which is free, Google Earth Pro can actually record animations that you can use. But there might be some advantages in Avid DS over Google Earth. In 3D DV, you can really play with the lighting, use different forms of anti-aliasing, really tweak your animation, and so forth. I'll let you figure out which is better for you, Avid DS or Google Earth Pro. I want to tell you a couple of things on how to import these images correctly if you're working in a 422 sequence. And this is where things get a little complicated, and if you lose me, that's okay, because I'll give you exact steps that you have to perform later. If you're in a 444 sequence, it's a lot more straightforward, but let's look at 422 first. As I said earlier, black value in a NED file or GeoTIFF creates the lowest elevation, and the pure white creates the highest elevation. And if we create a perfect ramp or perfect gradient between those two, that should create a perfectly straight line. Now, because of color management in 422, if you bring this file incorrectly, you'll get a straight ramp for a portion of the data, but then it will fall off pretty rapidly down here at the bottom, distorting the geometry of the object. NED files are linear files, and 422 color space is not linear. It uses gamma correction, not just in Avid DS, but in any box. Because of the 422 color management, when you link or when you capture the NED files, you have to make sure, if you're in 422 sequence, to use 601, 709 levels here at the input levels. So this would be the setting you would use for bringing in the NED. And if you do that, your NED will be interpreted correctly, which in case of a gradient from black to white, you would get a perfect ramp. If you do that incorrectly, if you capture with linear levels, which it will be a more logical choice if you select linear, you will get this kind of thing when the profile is not a perfectly straight line. So it is kind of counterintuitive, because you're importing a linear image, not as linear but as 601, 709, but that's how it works. And this is not a failure on the nomenclature part in Avid DS, it's just the way it is. It actually makes sense when you think about it, but for our purpose of kind of focusing strictly on these displacement elevation maps, it's just kind of counterintuitive. So this would be the elevation part. Now, when you bring in the texture map, the photographic aerial image, then you will use the input levels that are appropriate for that image. So for example, if you know that the image using sRGB, well, you would select sRGB. Legacy graphics would likely give you pretty good color as well. And if the image came from a video capture at 601, 709, that's what you would select, and so forth. So this all applies to 422. Now, when you're in 444, it's kind of opposite. You would use linear levels for the NED, not 601, 709 levels. Let's go ahead and bring in the Lake Tahoe images. So I'll link to the NED file first. So we'll go to 601, 709. Here's the Tahoe NED. Right-click, link. The reason I'm linking and not capturing is because these images are much higher resolution than my standard def sequence that I'm demoing this in. So if I were to capture, they would get captured at 720, 486 at NTSC size. But as you can see, this image is bigger than that. Not huge, but bigger. So that's it for the NED. Now we are going to switch this to Legacy Graphics, and I'm going to link to Tahoe Color. Link. Now we have all the elements we need to build an actual relief. So we'll take the Tahoe Color clip, load it in the viewer. As you can see, it's much bigger than the standard def resolution I'm working in. I will drag it onto the timeline and take it into a composite container. Here we'll drag Tahoe NED 10 meter relief, place it down here, and we'll take the 3D DVE. With 3D DVE selected, we'll press A on keyboard, which will add another input, and we'll feed the NED into the second input. So let's double click the 3D DVE. Click on the edit or pointer tool. The first object that's selected is the NED, which we actually don't need. So as long as it's selected, press delete on the keyboard and get rid of it. Next thing I do is not necessary, but it helps you keep your bearings straight. I'll select the color map, click on the little Y, Z, X button. We'll rotate the map minus 90 degrees, which will place it flat onto the ground. We'll also rotate this 180 degrees, and I'll show you later why. So now we have the red line is the color map, but we can't see it because the camera's looking straight at it. So we'll click on the camera button, and we'll lift the camera maybe 20 points up. Let's try 40 so you can see better. So as you can see, the South Lake Tahoe map is lined perfectly with the ground. The reason why I rotated Y 180 degrees is just to be able to look up the mountains. So if this is the north view, but if you look south, we'll be looking from the lakeside up the mountains. Next thing, we'll have the NED stamp punch this color map as if it were sheet metal. With the color map selected, click on the DV properties. Displacement texture, select input 2. Remember, that's where we fed the NED. And watch what happens when I select input 2. We'll change scale to maybe 20 to really exaggerate this so you can see the mountains. There you go. That's all we need to do. Now we have a relief. In order to show you how to manipulate some of these parameters, I'm going to feed a solid color instead of the texture map in here. So we'll step back out to the composite container, drag black down here, and instead of keeping it black, we'll make it some other color. And I will feed that in place of the color map. Double click the 3D DVE. The object is three-dimensional, but it's flat shaded, so you can't really see any articulation in the terrain. In order to see the terrain, with the object selected, click on Surface Properties and Enable Lighting. This is not something you would want to do when you're using a color photographic texture map, because you would be adding your own light with the light that's actually part of the texture map. We'll close that, and we're using the default spotlight, or actually it's a point light. So we'll click on the lamp, select the light in the scene, right-click on the light, light type, infinite. So now this acts more like infinite sunlight. We'll get a little closer to the object, select the camera, and clipping planes will reduce this to 0. If you don't, what's going to happen when the object gets closer, it will get clipped at the distance of 150, whatever that number means. But you want to be able to get as close as you can, so we'll keep that at 0. We'll click on the dolly, and we'll dolly in. And let's pan about there. As you can see, this relief looks like a really rough video game, and that's fixable. If we select the object, go to DV Properties. First, we'll reduce the scale to a more reasonable level. Let's try 10. And down here, Detail, we'll increase it to maximum, which is 10 for both X and Y. You can also play with softness, either decreasing or increasing it. It will soften the transitions, so you get more like a sand duny effect. And I'll put it back to the default setting of 10. The offset is something I usually put to 0, which I forgot to do this time. What it does is it really lines up the bottom of the object with your ground level. But now we have to lift the camera too, which we'll do by clicking on the camera. Let's type in 15. There you go. So we're looking down at the object. Go back to DV Properties. Now finally, scale. This is a tricky one. I don't know if there's a reasonable way to figure out how to dial in this parameter. It's somehow connected to the size. It's relative to the size of the texture map. So a scale of 10 on a texture map of 100 by 100 pixels is not the same as scale 10 on a texture map that's 1000 by 1000 pixels. So it's very, very difficult to dial in. Best, you'll have to kind of gauge it by eye and set it wherever it feels right. At scale 0, it'll give you a perfectly flat object, and it can go pretty high, give you unrealistic looking object. And now we're going to create a little animation. You can do it in two ways. One is to use the interactive controls up here, and you can also use numerical controls down here, or you can use a combination of both of those methods. So I will turn the auto keyframing on, and I will keyframe these values here at the first keyframe. Then I'm going to advance to the last keyframe of my little clip, and I'm going to use a dolly to push in. And now I'm going to type in let's try minus 20. This will pan the camera to the right, to the left. So minus 40. Here's a view of Heavenly Ski Resort, and roll angle to 6. We'll close the camera controls. Look at the camera curves that we just created. Select all the keyframes and click on curves, choose linear interpolation. And I will also click on clip to frame button down here to clip the output to the actual 4:3 frame of our standard def sequence. When I turn it off, we see everything that's outside of the frame, which is sometimes useful for positioning, but for composing the shot, it's easier to see what you're doing if you clip the frame. And we'll go back to the beginning, and let's try to jog through and see our little fly through. Good. You may have noticed that there aren't any controls for panning the camera. The way you achieve pan is by changing the interest point, the target point at which the camera is looking at. So effectively, that's the same as panning the camera around its X, Y, and Z axes. It's a different concept, maybe a little counterintuitive, because most 3D programs either have both methods, or they have the method where you control pan of the camera, tilt, and angle. You can create the same animation with manipulating the target of the camera, but it just takes a little bit of thinking how to do that properly. On the other hand, the method employed by DS is very good if you need to rotate around a certain point. So I enabled camera rotation. whatever I do, I'm spinning around 000 point. When you position a camera, sometimes it's helpful to switch to the alternate camera by clicking the switch button here and choosing the view. Right now we're looking top down, so the blue camera represents our scene camera. We can see left side view, front side view, and so forth. So when you're looking at it from the top, you will see our camera animation. And you can also grab this camera as an object and place it anywhere you want.